So in the last video, we saw how to find intervals of increase, decrease, local extrema using a sign chart. And we're going to work a little bit more with that with different types of question, but the same concept. So this next one is that instead of giving you the derivative algebraically and for you to create a sign chart, you're going to be given the derivative graphically and then create a sign chart. So remember that when we were doing it algebraically, what we did is we did two things. We looked at when the derivative was 0 and when the derivative was undefined. So you're going to do the same thing, but you're just going to do it graphically. So we're going to take a look at when the graph is 0. And remember, the graph is 0 on the x-axis. So there are two places that happens at -1 and 1. And so those are going to be our partition numbers. Because it's a parabola, it's never undefined. The graph is continuous, which is something we've learned in the past. So there is nowhere that it's undefined. So there's only two partition numbers, -1 and 1. And then you create your sign chart the same. And then you can pick a test number. So let's say I'll pick -2, 0, and 2. And then I'm going to look at the derivative. And remember that I was looking in the derivative, whether it's positive or negative. So if I look at -2, the point is about right here. Again, I don't really care where the point is. I just care with whether it's positive or negative. And it's about like a -9. So it's going to be a negative number. Then if I pick 0, the point is up here somewhere. That's about 3, but again, I don't really care. I just care that it's a positive number. Oop, I wanted to do that and stick to the colors. And then let's do 2. So again, let's put a point. 2 is about symmetrical, actually, because it's a parabola. So again, it's negative. So you're doing, again, the same sign chart. You're just doing it graphically, the plus and the minus. So I am decreasing. So I'm going to go down, and then I'm going to go up, and then I'm going to go down. So I am decreasing from -infinity to -1, union 1 to infinity. And I am increasing from -1 to 1. I have a minimum at -1 and a maximum at 1. Now, it's a possible sketch of f of x because you don't know anything about the y's. You don't have a function given to you, so you can't find the y's. But say, because -1 is a min, I'm going to put it a little bit lower. And because 1 is a max, I'm just going to put it a little bit higher. And I'm always label my mins and my max, and you'll see really why when we get into the next part of graphing. So I'm decreasing. I hit my min, I U-turn. I hit my max, I U-turn, and then I decrease. And again, I know nothing about my y's, so I do not label my y coordinate at all. My y-axis. Let's do another one. F of x is continuous on all real numbers. That's important. That means the graph is a continuous curve. Use the information given to sketch the graph of f of x. So this is actually really great. So what they do is they actually give you the sign chart for you. So you don't have to do any of the sign chart. It's given to you. You just have to be able to read the sign chart. So the first thing I'm going to do is at the bottom, it actually gives you some points. So I'm going to label those points. So if I take a look, the x's go all the way to 3 and the y's go to -3. So I'm going to go up to 4 just to give myself some space. So 1, 2, 3, 4. 1, 2, 3, 4 to the left. 1, 2, 3, 4 up. 1, 2, 3, 4 down. I'm going to plot my points. So -2, -3. That should be the easiest part. -1, 0. 0, 2. 2, -1. And 3, 0. Now, the next thing you're going to do is you're going to look at when the derivative is undefined and when it is 0. So ND means not defined. Okay, so in the thing, ND means not defined. And then 0 means that it's 0. So you have 3 partition numbers that creates your sign chart. And so what happens is you increase, you increase, you decrease, you increase. So let's take a look at the extrema. So at 0, I'm going to have a max. And at 2, x equals 2, I'm going to have a min. So I'm going to label that. So at x equals 0, I have a max, which it looks like in the graph, actually, once I pull out in my points. And at 2, I have a min. Now, the hard part here that we haven't discussed, which is something new, is going to be what happens when you have a not defined derivative. So when you have a 0, it means that you have a horizontal tangent line. So when you have a first derivative of 0, it means that your graph is either going to go up like this. All right, so you could have a horizontal tangent line here, a horizontal tangent line here. You could either go like this. This would be a horizontal tangent line if you go increase to increase, or it could look like this. All right, so that's a horizontal tangent line. When you have a vertical tangent line, it's going to either go something like this, where it makes a weird little peak, or it's going to go something like this. Oh, actually, I'm going to redo that. I don't like it. So what happens when you have a not defined is you have a vertical tangent line. Now it's making me lines. So it could be something like this. So you're going to have a vertical tangent line here. So that's when you have not defined. So the graph is going to kind of tell you which one it is based on whether it's increasing or decreasing. So what you need to do is you need to look at how you start. And then you're either going to U-turn if you have a max or a min, or you're going to continue by making the horizontal or vertical tangent line. So I begin by increasing. I know this because it's a plus. So I'm increasing. I'm going to make a vertical tangent line at 1. So I go vertical for a second. I go through this point at -1 all the way to my max. Once I hit my max, I U-turn. I decrease till my minimum. I U-turn, and then I increase again. So if you label your max and your mins, you'll know when to U-turn. So that's why it's really nice. And again, the not defined, just to reiterate, oh, that's not what I meant to do. Just to reiterate what happens is that you need to create a vertical tangent line. So here's a vertical tangent line, and at 0 and at 2, I have a horizontal tangent line. So when the derivative is 0, you have a horizontal tangent line. When it's not defined, you have a vertical tangent line. All right, let's do one more. The concentration, CT in milligrams per cubic centimeter of a particular drug in a patient's bloodstream is given by the following function. I'm going to rewrite it because I'm going to be working with it. And it tells me that T can only be between 0 to 12. And T is the hours. All right, so that's important. So, of course, it has to be greater than 0 because you're injecting the drug into the bloodstream. So it wouldn't make any sense to have negative amount of hours. So you're defined only from 0 to 12. Find the intervals on which the drug is increasing, decreasing, and the local extrema. So again, because it's a rational function, we're not graphing this yet. That's going to come later. So right now, we're just going to find intervals of increase and decrease. We need to create the sign chart by finding the first derivative. So T, it's a rational function, 0.3t. T prime is going to be 0.3. B is going to be t squared plus 9. B prime is going to be 2t. So C prime of t is equal to, cross, 0.3 times t squared plus 9 minus 0.3t times 2t all over t squared plus 9 squared. I'm going to distribute the 0.3. So I have 0.3 because I'm trying to clean up the top, all right? And then we're going to have 0.3 times 9, a positive, so plus 2.7, minus, and this is going to give me 0.6t squared, all over t squared plus 9 squared. And then when I combine like terms at the top, I get 2.7 minus 0.3t squared because the 0.6 is bigger than the 0.3. T squared plus 9 squared. Okay, two things. I need to look at when it's 0 and when it's undefined. So hopefully we're getting really used to doing this little guy. So when I set the derivative to 0, and once you get used to this, you can go directly to that. When you set a fraction to 0, you bring the bottom over, so you're really setting the numerator to 0. So if you understand that, you can go straight to setting the numerator to 0. So I'm going to move the 2.7 to the other side. It's going to give me a negative 2.7. I'm going to divide by 0.3, which will give me a positive 9 because they're both negative. And then I get t is equal to -3 and t is equal to 3. Okay, and then for when it's undefined is when the bottom is undefined. Remember, I only need to set one of the t squared plus 9 to 0. And then I get t squared is equal to -9, but a squared can never be negative, so this is impossible. So I have two partition numbers, -3 and 3, but, and this is a tricky part, you are using an application, and my domain is 0 to 12, so the -3 is out. So my only partition number is 3. So my sign chart is 0, 3, 12. Because I'm bounded. So be careful when you're doing applications. So here I'm going to pick 1. And here I'm going to pick 4. So this is x. This is, oh, I shouldn't say x. I'm sorry. It's t. T. C prime of t. And then when you plug it into the derivative, so you're going to have 2.7 minus 0.31 squared, which will be a positive in the numerator. And because the bottom is always being squared, it's going to be a positive. So that will give me a positive for the first derivative. And then when I plug in 4, you're going to have 4 squared 16 times 0.3 will be bigger than 2.7. You can do that in the calculator. It'll be a negative in the top, a positive in the bottom, so a negative. So let's look at what it was asking me. Increase, decrease, local extrema. So I am increasing from 0 to 3. I'm decreasing from 3 to 12. And that means that I have a local max at t equals 3. But you need to find the concentration. So you need to do C of 3. So we need to do that from the original function. So 0.3 times 3, which will give us 0.9, over 3 squared. Oops, 9 plus 9. So that's going to give us 0.9 over 18, which is going to give us a decimal. And that's going to give us 0.05. And we are in cubic milligrams per cubic centimeters, okay? So you have a local max at 3 hours, and the highest that the drug concentration is going to get is 0.05 milligrams per cubic centimeters, all right? So it's going to be 3 comma, cubic centimeters. So it's the drug is once they inject it into your bloodstream, it increases for 3 hours, hits its maximum, and then starts to leave your body. So this is an application, 3 application problems of how to use the first derivative sign chart and the test and the increase and decrease.